Okay. Any idea about this one?
Point L is transformed to.
Do you want to check?
So L is transformed twice, basically.
Yeah.
And so the 1, 0.
Oh, my mom's dead.
Okay, see you next time, Alexander. Sorry.
Is that like a column vector? The 1, 0 separately? Or.
Point L. Hold on. Point L is transformed by this matrix. It's point M. Point M is then transformed by this matrix. Transforms L to N.
Ooh.
Yeah, that's right. So these are the two things.
Would you add the 2 up?
Let's say L was 1, 1, 1, 1. So what would it be after it's transformed by this matrix?
So that would be, right, so 1, 1, 1, 1. That goes to 2, 3, 1, 4.
I believe you multiply them when you're transforming them, don't you? And it was this kind of way.
Oh, sure. Okay. Right, that's how you transform. So 1, 1, 1, 1. And then, so 1, 2, 0, 3. So you have this set and then that. So that's 1, 1 in one bracket, and then 1, 0. Then you leave a space, 1, 1, and 2, 3. Then you have 1, 1. You have 1, 0.
I believe it was times each other, wasn't it? 1 times 1.
The way I remember we did it was we had it kind of like factorizing brackets, but we'd only do half the operation, because you have 1, 1 in one bracket and then 1, 0. And then you do 1 times 1 plus 1 times 0.
Let's take a look. So it's transformations. Let's go to the simple ones. It's not simple about that. Transformations. -2, 5. So 2 times -2 plus 3 times 5. Yeah. So this one, you can see how it's going across here and going down here. And so it's 2 times -2 and then plus in the middle 3 times 5. And then -2 times -2 plus 1 times 5. So for a double bracket, no, we don't have much on double brackets. I'll just see if I do somewhere. So it's mostly single. So here's a double one. So it's going to be like that. So 5 times 3 plus -2 times 7. 5 times 2 times -2 plus p, and so on.
3. Okay,
So
right.
maybe just try this one, just to refresh your memory.
Yeah, sure. So 5 minus 2 minus 7, 3, and 3, 2, 7p. So then, so 5 times 3, then minus 2 times 7. 5 times 3 plus minus 2 times 7. and then you have 5 times 2. 5 times 2 plus minus 2 times p.
Yeah.
Then you have minus 7 times 3 plus, and then 3 times 7.
Yep.
And then we have minus 7 times 2 plus 3 times p.
Yes. And that's how you do these. So I can just skip back now.
Yeah.
And they go top left, top right, bottom left, bottom right. So this one.
Yeah. 1, 0, 2, 3. And then the first two. So we have 1 times 1 plus 1 times 0.
Mm-hmm.
And then we have, so that's that. 1 times 1. 1 times 2 plus 1 times 3.
Okay.
Then we have 1 times 1 plus 1 times 0. 1 times 2.
Oh, it's going to be the same, is it?
Yeah, it's just, yeah.
Okay.
3. Then we have, 1, 2 plus 3 is 5. And then we have 1 again, and then 5 again. So after the transformation,
Shall I simplify this?
yeah, so we've got 1, 5, then 1, 5.
1, 5. So that's after the first transformation.
Yeah.
Now about the next one.
The next one. So then you have to multiply this, the answer we got, by 0, minus 1, and then 2 minus 1. Okay, so that means that 1 times 0 plus 5 times 2. 1 times minus 1 plus 5 times minus 1. And then again on the bottom, no, that's so. Yeah, 1 times 0 plus 5 times 2, and then 1 times minus 1, and then plus 5 times minus 1. So you've got 10 minus 1 minus 5, so minus 6. Okay, so that's 10 again, and then minus 6 again. So 10 minus 6, 10 minus 6.
Okay, so if we started from 1, 1, 1, 1, and it became 10 minus 6, 10 minus 6, what transformation has happened now? Work out the matrix that transforms the point L to N.
Okay, so would we have to say that, would we have to minus 1 from each of the things here?
Why would you minus?
Because n minus 6, n minus 6. So the original thing that we had is 1, 1, 1, 1, and that became 10 minus 6, 10 minus 6. So for for that to become that, would you divide it by 1?
So I think just a simpler way would be, I suppose, if I start with the identity matrix, but you can imagine I just start with something let's say L, and
Yeah.
L is done by 1, 2, 0, 3, and then that answer is transformed by 0, -1, 2, -1. And so how would you figure out what L is transformed by?
Right. So is it the sum of the two things in the middle?
Why would it be the sum?
No, you multiply them.
Yeah. So multiply those two, what do you get?
Right. So you actually times 1, 1, 1, 1 by 10 minus 6, 10 minus 6. Or
No, just multiply these two. What do you get?
okay. So 1, 5, 1, 5 times 10 minus 6, 10 minus 6.
What do you see on your screen right now?
Oh, those. Oh, right. Oh, those ones.
Yeah.
Right. So 1. That is 1 times 0 plus 2 times 2. 1 times minus 1 plus 2 times minus 1. 0 times 0 plus 3 times 2. 0 times minus 1 plus 3 times minus 1. 4 minus 3. 6 minus 3.
I believe the first one was 5, was it?
5. 1 times 0 plus 2
yeah,
times.
1 times 0, so that's 4. Sorry, final answer for this one?
So I got 4 minus 3, 6 minus 3.
Minus 3. Let's take a look. So solution. Multiply the matrices in correct order. The unit square is this. Oh. 1, 2, 0, minus 3. Oh, point L is transformed by this to the point M. Point M is then transformed by this to the point N. From L to N. So you have to do them in reverse order. Note that the matrix for the second transformation is written first in the matrix for the combined transformation. So we multiply them, but in the reverse order. Note that the matrix for the second transformation is written first in the matrix for the combined transformation. So even though this came second, you do it first. Why is that? It's because of the order of operations. You're working from the innermost brackets working out. So we have to do the second one first and the first one second. All right. Yeah, so okay, if we'd done the second one first for a second, then that's what you get. Yeah, it's because the matrix inside a matrix, you're working from the innermost bracket out, and we just kind of save time by not writing everything in a bracket. We just kind of do them quickly. All right, we'll try this one.
Okay, so you just reverse the order that you multiplied.
Just reverse the order, yeah. And usually for multiplying that makes no difference, but for matrices it does, because it's a mixture of adding and multiplying. Okay.
So 1, 0, 0, 1 is the unit square, and it's transformed by 0, 1, 0, 0. So work out the matrix for the combined transformation and interpret the result geometrically. So that means, do we do 1, 0, 0 minus 1 times 0 minus 1? 1, 0.
1. What I would do is I would multiply these two first, and then multiply your answer by the unit square.
Fine, okay. So you have 1, 0, 0 minus 1.
Yeah.
And then you just, you times it by 0 minus 1, 1, 0. Giving you, what do you get? 1 times 0 plus 0 times 1. And then you have 1 times minus 1 plus, okay. 1 times minus 1 and then 0 times 0. Then you have 0 times 0 plus 1 times, or plus minus 1 times 1. Then you have, okay, so you have 0 times minus 1 plus minus 1 times 0. 0 minus 1. Then you have minus 1, 0. Yeah, 0 minus 1 minus 1, 0.
Okay, and what would you do with that?
So you have to multiply your. So you have to put the identity matrix first, and then multiply that by your answer here.
Yeah.
Okay, 1 times 0. 1 times 0 plus 0 times minus 1. And then you have 1 times minus 1 plus, okay, so 1 times minus 1 is 0 times 0. 0 times 0 plus 1 times minus 1. 0 times minus 1 plus 1 times 0. 0 minus 1 minus 1, 0. Okay, so you get the same thing because whenever you multiply anything by the identity matrix, you get the same.
So 0, minus 1, minus 1, 0. Interpret your answer geometrically.
Okay, so you've got basically two column vectors, so 0, minus 1, and then you got minus 1, 0.
Yeah.
That could be written as one vector, I think, because you've got two zeros. So you've got minus 1, minus 1. And you could say that that's, transformation by vector minus 1, minus 1.
So basically that's the B corner. So 0 minus 1 is 1 down. Minus 1, 0 is 1 left. And so the unit square starts here. It's now here. And so how would you describe the change?
You could say rotation by... Yeah, rotation... Yeah, sorry, so rotate by 90 degrees anti-clockwise.
That would put it here. 90 degrees?
180 degrees.
Yeah, I believe so. And that's A. That's B, that's C. Yep. Rotation by about the origin, 180 degrees. This one, 0. Combined matrix. Okay. Let's see. So, okay. So, are any of these worth doing?
Should we say try 2?
Okay.
Okay, the combined transformation. So the first thing you want to do is multiply 1, 0, 3 minus 2 times 3 minus 1 minus 2, 2.
Mm-hmm.
Okay, so I got 1 minus 1, 5 minus.
And so that's the single transformation?
That's a single transformation. I just want to check the order I did it. So 1, 2, 3 minus 2, 3 minus 1. Yeah, so that's fine. So then point W is minus 1, 4. And then you want the coordinate of W, of the image point of W.
Mm-hmm.
I assume that means the transformed point of W.
Yeah.
Okay, so that's so you could say that's like a 2 vector. So you have minus 1, 4.
Yeah.
And you'd put that first, and then you'd multiply that by 1 minus 1, 5 minus 7.
I don't think it'll matter what order, if it's first or second.
So that's quite fine. So that's is it minus 1 times 1 plus 4 times minus 1? Is that the first thing you do?
Yeah.
So minus 1 times 1 plus 4 times minus 1. And then you've got minus 1 times 5 plus 4 times minus 7. So you've got basically minus 1 and you've got minus 4. -1, -4, and then you've got -5, 7 4 is 28, -28. So that's actually a 2 by, like a 1 by 2, a 2 by 1.
Yeah, it should be.
5, -5, -33.
Yeah.
Okay, great.
-5, -33. Any questions there?
We have to write this as the coordinate, so would that be -5, -33?
Yeah.
I think I've got the idea now. That's good.
Yeah. -5, -33. And yeah, sometimes they'll often call it W dash or W prime.
Right.
That's the image. The unit square is reflected in the x-axis, followed by rotation, center to origin. Whew. Right, we better do these. This is the last thing in matrices, I believe.
The unit square is reflected in the x-axis and rotated 80 degrees. The origin center, and then work out the matrix of the combined transformation. Okay. So 1 0 0 1 is, so yeah, the unit square, and then you reflect in the x-axis. So that's kind of, might help to draw it out actually. So like this. Reflected in the x-axis means it's kind of, right, that's going to be A dash, B dash, C dash, and then the origin remains there. And then rotated 180 degrees from the center of the origin. So that means it goes, the C goes to, the C goes somewhere here. Then it actually moves somewhere here. C double dash would be there. I imagine so. Do you know in the exam if we'd get like tracing paper or something?
I'm not sure. You shouldn't need it though. So after your first transformation, what will you get?
You've got
Or what happens to it?
it's just in the bottom right quadrant, and you've got the origin stays there, and then A is just directly under the A there, A dash. Yeah. And then I got B kind of below that, and then C to the left of that.
Okay, so if you rotate that 180 degrees about the origin?
Yeah, so that would mean that, oh, right, so B dash would be on the outside.
In which quadrant?
Okay, so this would be in the top left quadrant.
Yeah.
And then B double dash would be the farthest to the left, so you go up by...
Mm-hmm.
Yeah. And then C would be... would C just be at the bottom? Like, bottom underneath B?
So it was here.
Yeah.
Rotates 180 degrees, half a turn.
Oh, fine. So that would just be where the original C is?
Yeah.
And then you've got A will be the other point, just below B. Right.
So describe that as a single transformation.
B, C, and A. So you reflect the unit square in the y-axis.
Yes. So you do just take them one step at a time, and it really helps to have a diagram. Okay. How about this?
Okay, so the unit square is enlarged center of the origin, scale factor 2, and then reflected in y equals x. So I'll draw the unit square again, and if it's enlarged by scale factor 2, that just means all the coordinates are like, so you've got the O and then so the A would just be twice as far away now. So you could just put A here. B would be like that. Again here. You would be. So you just draw it like so O to A, and then you have another of the same distance. So if you draw like the unit square and then kind of enlarge it by scale factor 2, it's the same. The coordinates are in the same places, but they just move up by twice as many steps as before.
And so where is A, where is C?
So A is the coordinates would be 0 to 0.
Yeah.
And the coordinates of C as well. So C is 0, 2.
Okay. And then next one.
Okay. You have to reflect this in the y equals x line. So that just means that the places of C and A swap.
Yes.
And I think B remains the same because that's in place. So that means that you've got 2, 0, 0, 2 becomes 0, 2, 2, 0.
I believe so. 0, 2, 2, 0. Yeah. The x swaps with the y.
Yeah.
Work out the matrix. Yeah. So not the transformation, but just the matrix. Do we need to do question 5? Or would you like to do
Please. I think I could be fine with that.
I think so as well. What is question 6? Good night, Pat. So any idea about 6-1?
What does it mean, the transformation? So is it just minus 1, 1? Because the 0 you could...
Or what would it look like? What would the unit square look like if it was changed into this? Where would it be?
Fine, okay. So I might just draw a diagram again.
Okay.
So you've got 1, 0, 0, 1, and then that becomes, so you transform it by p. So 1, 0 minus 1, 0. So that's a reflection in the y-axis.
Mm-hmm.
You've got A here. D stays in the same place, and then B just moves with A. Or B dash, A dash. And then describe the, so yeah, reflection in the y-axis. Then work out p squared. That would just be it times itself.
Mm-hmm.
So minus 1, 0, 0, 1 times, again, minus 1, 0, 0, 1. Same. You've got 1, 0, 0, 1. Okay, so p squared.
And then interpret your answer.
Transformations to interpret 2. Does that mean it stays in the same place?
And why is that?
Because if you multiply anything by the unit square, it remains in the same place.
So it went back to 1001. Initially, it went to, in terms of transformations. So what was the initial transformation?
Minus 1, 0, minus 0.
And like, what is that as a transformation?
Oh, reflecting the y-axis.
And so what's the significance of p squared?
So that's another reflection in the y.
Yes. And so why did our, so use that to make sense of the answer?
Yeah. So you reflect in the y-axis twice.
Yeah. So reflect in the y-axis, reflect back in the y-axis, and so it just returned to where it began. Oh, there's more. All right.
D is 0 minus. Okay, so 7, that's a reflection.
Reflection, what's it?
In the y-axis. No, wait. Zero minus 1. So that you.
What if, what if the -1 was plus?
Then it would just be the square but in reverse.
And so what would do that?
Is it rotate 180 degrees?
This, it's usually 1001.
Oh, fine. No, yeah. You reflect in the in y equals x.
Yeah.
And then that becomes -1. So reflect in y equals x. And
then what, sorry?
So is it reflect in the y-axis?
So the y changed sign from plus to minus?
Oh, the y changes. Then reflect in the x-axis.
Yes. And we have to figure out that as one single transformation. So that became A, that became C. B stays the same. And then it's a reflection in the x-axis.
Yeah.
Okay. And
Wait.
so
Reflection.
so I just didn't, so originally it looks like this. A is there, C is there, B is there. This is what we end up with.
But would the reflected thing be in the bottom right quadrant?
Yes. So it should be down there, sorry. If it's a reflection, so that would be -A.
Right.
Sorry, -1. Okay. And so what is that?
Run the transformation that matrix E represents. E is -1, 0, 0. That is the 1, 0, 0 original. So would that be a reflection in the y and then the x-axis, which is the same as a rotation by 180 degrees?
Not 180. So it starts here, ends up here.
Oh, sorry, by 90.
And if it's by 90, you have to say direction.
Yeah, clockwise.
And about what point?
About the origin.
Yes. That's it. They're not messing around. Okay. Part 2.
Describe the so we've done that. And then work out D, so that's just multiplying.
Did we do part 2?
So
this was part 1. Reflection in y equals x, then a reflection in the x-axis is a rotation 90 degrees clockwise about O.
Oh, sorry. And then E 1, 0, 0, -1. So that means that it's a unit square, but the 1 becomes 1, 0, 0, 1. I'll just draw it out to help. So then minus 1, 0. So A goes to it's a reflection in the y-axis, but then you reflect this again in the x-axis because you've got 0, 1 to 0, 1.
Mm-hmm.
So A double dash would stay in the same place, but B would move to the...
So the way I did it is, this is like A, and this is like C. And I suppose the one that you always like to do is this one being like B. So A is usually 1, 0. It's now minus 1, 0.
Yeah.
C is usually 0, 1. It's now 0, minus 1. And B is usually 1, 1. It's now minus 1, minus 1.
Okay, it's a lot easier that way because B just follows where A and C are, right? Okay. So you're in the bottom left quadrant, and that is the same as a rotation through 180 degrees from the origin.
That's it.
Doesn't matter which direction, I don't think.
Yeah. Okay, 3 DE.
Of DE. Okay, you've got 0 to... It's just a normal way. I'll do it and then see if the answer's right.
Okay.
Okay, I got 0, 1, minus 1, 0. What do you?
0, 1. Like that.
0, minus 1, yeah. 0.
Okay.
Matrix DE represents. So, this is reflect it in the line y equals x. Then you... So I'll draw this out, yes.
So I was just drawing the previous one.
Yeah. So I'm just drawing where A would go and then where C would go. So 0, 0. We go to 1, 0. So C is here, and B comes there. So that's just rotating it through 90 degrees, clockwise from the origin.
Okay. So that's a rotation clockwise about the origin.
Yeah.
90 degrees. I believe. So that's DE, is it?
Yes.
Let me just check. 0 minus 1. That's a 1, 0. And then question 5.
Question 5. So use transformation to interpret your answer to 4. Transformations, that would be a reflection. No, it would. Yeah, is that not a transformation? Rotate 90 degrees clockwise. Okay.
Oh, okay. And then use transformations to explain why ED is equal to DA.
Because ED, we haven't marked that out. No. So that would.
So I think, do you have to work out ED?
I don't think you do.
Okay.
You have to explain why that they're the same. But I don't know how to prove that they're the same without having to solve them.
ED would be the same as DE. Let's see. So D. I think. Oh, I don't know which one. Let me just go into a new thing. Just want to make sure. So D. So it's always C, A, B. So this one is 0, 1. So now A dash is up there. Minus 1, 0. So that's C dash. And that's B dash. So I think the matrix D is a rotation anti-clockwise by 90 degrees about the origin. I think what this one represents is that.
Yes.
So that's rotation 90 degrees anti-clockwise about O. So then E. So A is minus 1, 0. Well, A dash. A is there. C. B. Okay, so A dash is there. 0 minus 1 is here. So that's C dash. And that must be B dash. So that's rotation 180 degrees.
Yeah.
About. Oh. So Y is doing a 90 degree rotation and then a 180 degree rotation, the same as anti-clockwise. So okay, so we do 90 degrees, so we end up here. So if you do a 180, after that you end up here for this one. So we'll do this one first and this one second. So we'll do DE and then ED. So
Okay.
this green one is the rotation 90 degrees anti-clockwise followed by a rotation of 180 degrees.
Yeah, I understand that.
And then this one is rotation 180 degrees followed by a rotation of 90 degrees anti-clockwise, which is there.
It's in the same place. Okay.
Yeah. And so, how do you explain that in words? I don't know, because a rotation 90 degrees anti-clockwise about O, and then a rotation of 180 degrees about the origin is the same as a rotation 180 degrees about the origin, and then a rotation of 90 degrees anti-clockwise about O.
Yeah.
So it's less clear in words, but I imagine they're looking for a worded answer.
Yeah.
Yeah. So that was questions. Any questions about that?
I understood that. Yeah, I got it.
So I think the best way, yeah, is like this is A, this is C, and then diagonally is B. And then the only thing we didn't get to was question 8. To prove that an enlargement center origin followed by an enlargement center origin scale 2 is equivalent to an enlargement center origin scale vector K, where K is an integer. Okay, so just a crazy question at the end. Key points. So to multiply matrices, yeah, so the first one is down and along, down and along. So you do it that way, and you end up with the 4 things. If matrices are equal, the elements can be equated. So that's for finding the unknowns. That's the point, can be transformed. If the matrix, then that is the transformation to an image. Okay. Using matrix A is a combined transformation. So the combined transformation is BA, not AB. Yeah, and that's the end of further maths anyway. So anything in particular you want to do next time? We could resume GCSE revision, or we could do further maths revision.
If you know where you can get a further maths past paper to email me for like homework, I think that'll be good.
Okay. And anything in particular you want to do next time, or you'll just kind of look at the paper?
Tricky now. I think so. We've done further maths, and we've pretty much done GCSE maths. I just need to practice and practice. So if you email me maybe a couple of papers, and then I'll try and find the tricky questions, and we can go through that.
Okay. Any questions for me in general?
Yeah, just if you could email the slides like after the lesson, because this was quite tricky, this topic. So just so I can revisit it and just make sure I understand it.
Okay. Anything else?
No, I think that's it. Thank you.
All right. Well done, Stefan. You did great. I look forward to talking again next week.
See you next week. Thank you.
Have a good week. Goodbye.